All right, today we're going to cover Chapter 22, Electric Currents. So the first section is on current and circuits. So the first thing you need to know is what exactly is electric current? It is a flow of charged particles. That's your definition for electric current. Current is going to be measured in amperes, capital A. So if you see 10A, 10 amps for short, that is your current for your problem. Electric circuits are any closed loop or conducting path that allows electric charges to flow through it. Power. We've talked about power before. The rate of energy transfer or flow of charge. So we've talked about power with work and power with energy. Now we're talking about power with charge. Power is still measured in watts, so capital W. And in this case, because we're talking about electricity here, there's a different way to find power. So power can be found as P equals I delta V. So P is your power, W. I is your current, capital A. And then V is your voltage in capital V. Okay, so the only one I see you guys having trouble with will be capital I. That's your current. Okay, that's the only one that's kind of out there and a little bit off. So here's an example. A 6.0 volt battery delivers a 0.5 amp current to an electric motor connected across its terminals. I want to know what power is delivered to the motor. And then I want you to find, if the motor runs for 5 minutes, how much electrical energy is delivered. So P equals IV, we're looking for power. That was the first question asked. So we have our I, that's 0.5, and we have our V, that's 6. So 0.5 times 6, 3 watts. Pretty simple math, right? The second thing is finding, if it runs for 5 minutes with that power, what energy do you have being delivered? So we're going to go back and use that formula from the energy section, so from chapter 10 and 11. So power equals delta E, that's your change in energy, divided by the time. So we have P, that was 3.0. We have our time, which was in minutes, so we need to change it to seconds. Okay, once you do that, you can go ahead and plug in, and you should get about 900 joules of energy for 3 watts of power. Okay. There are some practice problems that I would like for you to do on page 1388 in your iBook, number 1 through 6, and you can stop the video now to do those, or you can wait and come back at the end. Just make sure you leave enough space in your notes for those. Moving on, we're going to talk a little bit about diagramming circuits. You'll have an assignment later on that helps you to diagram these. Page 1389 in your iBook will help you to look at diagramming a little bit more. But these are some things that you need to know about diagramming. Anytime it's just a conductor, which everything in this case will be, you're just going to use a straight line to connect things. Resistors, okay? Resistors we're going to draw as this jagged zigzag line. And we will be drawing some resistors in when we start diagramming circuits. We will not be using switches, fuses, capacitors, inductors, or potentiometers. We won't need to talk about grounds, but you will need batteries. Okay, so when you draw your battery, you will need these 4 lines to depict where your battery source is. We won't do DC generators. We might do some lamps, so keep in mind it's kind of just this W shape inside of a bulb, so it looks kind of just like a light bulb, only from the top view. We might use some voltmeters, so that's just a circle with a V, and we might use some ammeters, so a circle with an A. So moving on and talking about resistance, it's the measure of how strongly an object or a material slows down current that's produced by a potential difference. Okay, so it's how much resistance or how much it's slowing down the flow of charge. Okay, resistance is measured in ohms. It's the Greek letter omega. And there is a way to find resistance. It's called Ohm's law. And there are a couple of ways that you can write this, but for today we're going to write it as R equals. So R equals delta V over I, where R is your resistance in ohms, V is your voltage in capital V, your volts, and then I is your current in amps. So what exactly is a resistor? It's a device that's designed to have specific resistance, so to slow down the flow of charge by X amount. You have resistors in, especially in the electrical wiring of your home. So carbon is a good resistor, semiconductors, anything that's really a long, thin wire can be considered a resistor. So for example, let's try to find resistance here. We have a 30-volt battery. It's connected to a 10-ohm resistor. We're actually going to find current for this one. So what is the current in the circuit? V equals IR is another way to write that. This is how you will see it in your reference packet, so don't get confused by that. So V, that's 30. I, we do not know. That's what we're looking for. 10 is our resistance. It's in ohms. So 30 divided by 10, your I is 3 amps. There are some practice problems that go along with this on page 1397 in your iBook, number 13 through 17. So if you will do those, you can either stop the video now or you can come back at the end and put those in your notes. Now, I will be collecting your notes at the end of this week, so make sure you do have these problems finished for each video section. There are types of connections that we're going to talk about. We'll talk about different types of circuits in the next section. But parallel and series connections, this connection is different than the type of circuit that it is. So a parallel connection, you have 2 or more paths to follow in a circuit. And then a series connection, there's only one path that current can follow. So section 2, how we use electrical energy. So we talk about power and electricity. It's the rate at which energy is transformed in a resistor. Okay, so P equals I squared R, or we could write it as P equals delta V squared over R. Okay, both of those would be correct. And I do believe both of these are on your reference packet, but you can double check to be sure. So an example, if you have a heater that has a resistance of 10 ohms, it operates on 120 volts. I want to know what's the power of the heater. So we're going to use P equals delta V squared divided by R because we have ohms and volts. So let's just go ahead and plug in 120 squared divided by 10. You should get 1,440 watts. And again, there are some practice problems on page 1407. It's number 26 through 29. And again, you can stop the video now or you can come back to those at the end. Just a couple more things and we're done. So superconductor is a term that you'll need to know. A superconductor is a material that has 0 resistance. Okay, so that means that the flow of charge is moving freely. There's nothing to slow it down at all. And kilowatt hours, we've talked about kilowatt hours before when you guys brought in your energy bills. So it's a measure of energy that's equal to 1,000 watts of power delivered continuously for 3,600 seconds. Okay, and remember, kilowatt hour is your power, that's in watts, kilowatts, multiplied by your time, your hours, to give you your energy. And there is some practice with kilowatt hours on page 1411, and that's 31 through 33. Okay, so we are done for today, and we'll continue with circuits and electricity tomorrow.